Hey everyone, so today we're going to be going over the basics for linked lists inside of JavaScript. We're going to be going over singly linked lists, which means it's only pointing in one direction. We're going to go over a couple things, including why they're useful, as well as some methods, for example, how to append data, how to traverse the linked list, and also how to find if a certain value exists in that linked list. All right, so you can see here on my screen an example of a visual of what a linked list might look like. On the top here is just an array, and we're going to be going over what these terms mean and what's going on here. Now, the reason they're called linked lists is because each element in the list is actually linking to the next element through a reference called a pointer. And we can just represent those pointers visually as these arrows here. So foremost, linked lists are actually dynamic data structures. And that means that they can actually grow and shrink in size as needed. This is in contrast to arrays that have a fixed size and actually require more memory to be allocated upfront. So in terms of memory in a computer, let's just say that we were to set this as like let array equal this array, right? So what's going to happen here, let me make this a little bit smaller. So what's happening here is upfront right away, we're saying to the computer, I need you to make an array and I need you to put all these values in there. And so the computer will grab all these values and store it in contiguous memory, which means that it's very important that it keeps it in basically one spot of memory and everything is sort of in front of each other. So it knows the memory 1, 2, 3, 4. It sort of bunches everything together and it has to stay in that order because if it goes in any other order, then it's not really an array. It needs to be in a certain order. Versus a linked list, you can think of these circles as nodes. And what's going to happen is we're going to go over this, but the nodes basically have two properties. It's going to have a value, which would be, for example, A in this situation or B in this situation for the second node. It's also going to have a pointer looking at what's next, what's in front of A. Well, obviously B, but what's in front of B? C. And so what the computer sees, and by the way, I just made this A, B, C to make it a little bit easier to understand, is the computer says, okay, I see node 1 here. It has a value of A and it has a next. So that's stored somewhere in the computer's memory. Then it says, okay, I see node 2 here that has basically a B and it's pointing to another node here. For node 3, it can see that it has a value of C and so forth. So all these pieces of memory are kind of different places in the computer's memory. Versus with an array, it has to keep track of everything in one spot because it's very important that all these values are basically together in one piece. Now, because everything doesn't need to be squeezed together like it does for an array in memory, this makes linked lists actually use less memory than arrays because they don't need to store the data in contiguous blocks of memory. So this is super useful for dealing with large amounts of data or when working on systems that have limited memory, for example. That being said, since everything's a pointer, it does have limitations. We can't just jump all the way to C, for example, right away if we want to grab that value. We have to traverse. We have to go like from node 1, we have to point to node 2. Then from node 2, we have to look inside node 3. So we have to traverse that in order to grab that information. Versus an array, if I want to grab C, for example, I could just do array at 0, 1, 2. I can do array at 2 and grab C. So I know this is a lot of information to kind of take in, but I promise as we code it out, it'll make more sense. So let's jump into the code. And again, I'll try to provide examples and I'll console log things out so that way it'll make more sense for you. So let's jump over to our IDE. Okay, so first up, we're going to create the node. So let's just go ahead and create a class node. And inside that, we're going to, of course, have a constructor, and we're going to pass in data to this node. So that data, for example, would be like A, B, or C. Whatever the person's passing into the node is going to be the data that's stored. So we'll do this dot data is equal to data. Sometimes people do this dot value or this dot val. So you might see a variation of a linked list or a node like that. So just keep that in mind. And then we'll do this dot next is equal to, we're going to set it to null at first because when you have a new linked list with nothing inside of it, so let's say I created a new linked list and I only had A in there and there was nothing else being pointed to, then basically that would be null, right? Because there's nothing there. So we want to set that as null up front so that way we don't have some sort of value here because we don't know that until we assign the next. So at first the next will be null. Okay, so that's it for creating a node. Pretty simple, right? So next up, we'll create the actual linked list class. So we'll create a class called linked list, and we'll go ahead and put a constructor in there. And the linked list will have a head. So the head will basically be the topmost value that's put into the linked list, and everything sort of follows afterwards. So at first, we won't have a head, obviously, because nothing's been created for this linked list just yet, but we'll put that in relatively soon. You can also put a length, and that's kind of important if you want to see how long the list is getting, or if you want to put limitations on how long this list is becoming. If you saw my video on stacks, for example, you could put a max length of, let's just say 10, for example, and then you can stop it past that point. But you can also use length in this case to kind of do a quick check on like, okay, how long is my list getting? Can I return a number here? Like, let's say it's at 100, then you know if you want to get an element at the end of the linked list, it's going to take, you have to go through every single element, and you're going to have to go through 100 elements in order to get to the last point. So that's just something to kind of keep in mind if you want to have a length for this linked list. And that's it. We basically have our linked list here. So if we wanted to, we could say, for example, const list is equal to, and we do a new linked list. And then if I console.log list, you can see that I have no head and I have a length of 0. So that's all we have so far. So in order to actually add something to this linked list, we're going to need to create a method here, which we'll just call append, which will take in a value and then add that value into the linked list. Okay, so let's go back here. We're going to create a method just called append. Now it's going to take in a piece of data, right? Because we need to put in data into this linked list. So we'll add that there. So first up, we want to create the actual node and then add it onto the linked list, right? So for example, let's just say that I have another value here that I want to add. Let's just call it, for example, E. I need to create this, piece of data first with the E, and then basically do something with it. Like, if I'm going to be adding it, of course, I have to point through or look through all the pieces of the linked list and then add it to the end, for example. But I need to make this first so that way I can add it. So in order to do that, what we're going to do is on this append method, and let me just move this up, we'll just say const node is equal to, and then we'll do a new node, and we'll pass in the data that we want to add to the node. So we'll just put that there. And remember, this data is going to be passed in when you call the function, or the method rather, on linked list. Okay, great. Now remember what I said about head, right? So head is basically the top of the linked list. Since our linked list here has a head of null, meaning nothing's inside there, we have to add that to the head to be the first piece of information coming into the linked list. So very simple here. We're going to do an if check, just checking to see if this.head is equal to null, then we want to basically take this.head is equal to node. So if we try this out really quick, let's go ahead and go back here. So we're going to say list.append, and let's just add the number 5, for example, right? Now you see that when I console log out list, the head is pointing to a node, and that node has data, which is 5. But now this node has its own next, but that next is null because it doesn't point to anything. So what basically happened was we created if I were to make this 5, we have this 5, and the next is pointing to nothing. It's pointing to null. Now we need to create some extra functionality here, because what's happening is that if I were to do, for example, list.append, and let's just say add the number 10, it's not going to work, right? Because we're checking at first to see this linked list, is the head equal to null when we're running list.append 5? At that point, yes. So this.head is now equal to 5. When we run it a second time with list.append 10, this.head is not equal to null anymore. This.head is equal to 5. So this statement never runs. So now we need to create an else statement to do something with this data and make sure that we're actually able to append it where it belongs. So the current situation that we're in is that we have this 5 created in the linked list, right? But the next right now is null. There's nothing in front of it. And we need to basically find that next and then create a new node inside of there to be pointed to. So the way we can do that is, again, we have this functionality where we're saying that this.head is equal to node. That's great. But if we want to add something onto there, what we're going to do is we're going to say, first of all, we're going to say let current equal this.head. So we're pointing to the head to make sure that we're starting at the top, because again, we're going to traverse from the head all the way to the end, which is called the tail. So we'll use a while loop to sort of iterate through this, and we'll say while current.next is not equal to null, we want to do something. And what that something would be is we're going to set current equal to current.next. And so what it's going to do is it's going to keep on iterating through the current and the current.next until finally that current.next is equal to null. And then after we go through all those iterations and finally current.next is equal to null, meaning it's not pointing at anything, now we want to set that current.next equal to the new node. So we just say current.next is equal to that node that we created. And so if I go to list.append and I add, for example, 10, you'll see what's happening is we have the head, which has a node which has a data of 5. And then we have that next, which is pointing to a new node, which has the value of 10 for the data. And now the next for that one is null. So if we add one more value, so let's just say list.append, and we'll add, for example, 20, it traverses through. It goes from this 5 to this 10 to now this 20. And now instead of that next being null from before when it was 10, now that next is pointing to that new node that has a 20 in it as a value. Now after all this, we'll just do this.length plus, so that way we're able to increment the actual length of the array. So if I console.log and then just do list.length, you'll see it's now 3 because it has 3 elements inside of it. All right, so I know that was a lot, so let's go over this one more time to make sure you fully understand what's happening. We have, the first time we're doing the list.append, we're putting in 5, right? So the first linked list has nothing inside of it, so the head is equal to null. So we're saying if the head is equal to null, then basically the head is equal to the node that we created with the data. The next time around, we're appending 10. The head is no longer null because it has a 5 inside of it. So instead, what we're going to do is hit this else statement. We're saying that the current is equal to this head, and while current.next is not equal to null, we're iterating through current. The first time around, since let me just comment these out. Since the next here is equal to null, it's already equal to null. So this wouldn't work anymore because current.next is equal to null, as you can see here. So we're just going to skip this while loop and go to current.next is equal to node. So we run right to line 23, which is current.next is equal to node, basically meaning that this next right here is going to become the new node that's passed in with the value of 10. And so at this point, instead of next, you can see data 5 next is null. Data 5 next is node now, because now we put in that node and that has a data of 10, and now that node's next is equal to null. Then we go to list append 20. We've already created the node and we're basically navigating through until we hit a next that is null, because at that point we know, okay, now we have to add it to that next. So we set current as this.head, so we know right now we're looking at this node because this.head is basically pointing to this node, right? And we're saying, while current.next is not equal to null, so in this situation, current, which is this head, the next is not null, right? Because it's pointing to a node. That node is this node that contains the data of 10. So we're saying, while current.next is not equal to null, then current is basically equal to current.next, meaning current is now pointing at this node, right? And so, okay, so now we're here. Now we're asking, is current.next not equal to null? Well, in this case, when we hit this node, next is equal to null. So because it's equal to null, we no longer qualify to run this while loop. So that means we go over to this portion, which is 23. Current.next is equal to node. Node is that node of 20 that we made. So basically what we're saying is, at this point, current.next, which is here, which is null, is 20. It's creating that new node, which is 20. So now this is no longer null, this is node. And so now what's happening is the data for this one is 20, but now this next is null because it's not pointing to anything. So that means if you want to add one more value, you have to traverse through all of these next until we finally hit this one because this next is equal to null. And we say, okay, now this next is equal to that new node that we've created. So again, it's going to take a little bit of practice, but hopefully that makes a little bit of sense. Feel free to play around with this code a little bit until you understand it. If you have any questions, please drop it in the comments. I'll try to answer them. But let's continue here. So we know how to append data. So that helps us with not only traversing the actual linked list, but appending data to it. So let's try to figure out a way to check if a piece of data exists in this actual linked list. So we'll do a method just called contains. And of course, we're looking for a value passed in to kind of compare that against the linked list to see if it exists. So very similar thing. What we're going to do is we're going to say let current equal this.head, but this time we can't do current.next as the while iterator, because what's going to happen is that if we're looking for, let's just say the number 20, if we say that, let's just say we're traversing and we're on 10, and we say, while current.next is not equal to null, well, in this situation, current.next is equal to null, so we'll never get to this node here. So instead, what we're going to do is say while current is not equal to null, so not the next, but the actual thing itself is not equal to null. And inside of here, we're looking to see if that value is there, first of all, right? So we want to say if current dot data is equal to the value that's passed in, then all we want to do is return true, because we know at that point that yes, it does exist inside of this linked list. And then in order to traverse the linked list, we'll just say current is equal to current.next. So now we're iterating through it to make sure we're going through all the nodes inside of the linked list. And then eventually we're going to hit all those nodes, right? And we're going to get to the point where, let's just say we have 20, right? So at this point, what we're going to do is, let's say we're looking for the number 400, right? And obviously it doesn't exist here. When we get to this point, we're going to say, well, current is not equal to null. So basically this current node is not equal to null. We're going to set current equal to current.next. Well, current.next is null, right? So we're going to basically be setting current equal to null. So at that point, we know we've traversed the whole linked list and it doesn't exist. So basically outside that while loop, we can just return false because we know at that point we never even hit it. So we'll return false. So let's try it out to see if it works. So we'll do console.log list.contains, and let's try out the number 5, right? It does contain 5. That's great. What about 100? 100 is false, right? Because it doesn't actually have that number. What about 20? 20 is true because it's in there, and so is 10. But any other value would not be in there. So if we put the number 300, for example, that would be false. Unless, of course, we append and then add 300. Now that's true. Thanks so much for watching my intro to linked lists. If you found this valuable, please do like, comment, and subscribe. It does help my channel to grow. I'm going to set a goal. If I can get 20 likes on this video, then I'll go into doubly linked lists and kind of go over the methods there and the main differences there. So if you can make that happen, that'd be awesome. And I would love to kind of create more content on linked lists. So please do vote by thumbing up. Thanks again for watching. If you have any questions, please drop them in the comments and I'll try to get to them as soon as possible. And I'll see you in my next video.